example, we are going to start with C class, which we give some very good basic idea on exactly how the subnetting process goes. Okay, so I'm going to take one question, any question you can take. So first we'll start with FLSM, where we divide all the networks with equal sizes. I got some tables here. These tables will give some more in detail idea on the power table. So the first requirement is, I have a question here. The requirement is 40 host using a C class network, 192.168.1 network. So the question here is, let me write down the question here. The question is, the requirement, I have 40 hosts and I want to divide this by using any C class network, or specifically if the question says 192.168.1 network, you can use any C class network. So whatever the class, whatever the address, if it is C class, the calculation remains the same. And we already know that a C class network supports how many addresses? Default it supports 256 addresses, because the range starts from 0 and ends on 255. I don't want 256 network size. I want to divide this C class network into small networks such that each and every network should get minimum of 40. It can be more than 40, but it should not be less than 40. That's my question. So now here, now we are doing as per the host requirement. Let's say I want to divide this. So that is my requirement. So we need to take 2 to the power of h value. So the formula is 2 to the power of h minus 2 greater than or equal to requirement. In my example, the requirement is 40. So now minus 2 remains the same, 2 remains the same. So now we need to take 2 to the power of h value. Now we have to find out what value satisfies this condition. So to understand this, you should have a clear understanding on 2 power table. If you see here, I got 2 power table, 2 power 2 is 4, 3 is 8, 16, 2 to the power of 5, 32. If I take 2 to the power of 5 also, it will not satisfy my condition, because my requirement is 40. And 2 to the power of 6, 64 satisfy my condition. So which means, what is the value I have to take here? I have to take 2 to the power of 6 value here in order to satisfy my condition. So 2 to the power of 6 becomes 64, but still I need to do minus 2 for network ID and broadcast ID. So this minus 2 I am doing for network ID and broadcast ID. Even though I get 64 addresses, in that 64 addresses I cannot use the first address and the last address, which means 62 is your maximum valid host addresses which I can use in my network. In case if my network size goes beyond 50, beyond 40, 41, 42, like that, maximum I can connect only 62 devices. So from this example, we understand that we cannot divide exactly 100, because exact 100 is not possible. The possible size here is 2 to the power of 7, 128. If I have a requirement of 200 hosts, exact 200 is not possible. The possible size is 256. So you cannot divide a network exactly, but you can only divide to the nearest value. So here also I cannot exactly divide 40. So exact 40 is not possible. The nearest possible size is 64. If you want, you can use 128 also, but again it is more wastage. So out of 40, 64 addresses, I'm using 40, which means I'm just not using 24 addresses. So it's far better than using the default network. If I use default C class network, 256 minus 40 means I'm wasting more than 200 addresses. So you have to always select the nearest possible size from the 2 power table. So this is the first step of calculation. So when I do first step, when I do the calculation, please try to only follow the step-by-step procedure, because when we do subnetting, we probably try to get into some other things as well, which will again in turn create a confusion. So first, try to understand the step-by-step process, how the calculation process goes, and once you understand the step-by-step process, probably we can get into more in detail, like how they become different networks and how they become network ID, how the device will understand. Probably you may have many questions like this. We get into that later on in our next examples, but the first example I purely dedicate for understanding the step-by-step calculation process. So the first step, finalize how many bits. So from this I understood that, okay, whatever the power value you get, that is your required host bits. That's your required host bits. How many required host bits? 6. Now, in general, we are talking about C class, right? So a C class network supports 3 network portions and 1 host portion. So network always represented with ones, 8 ones. This network 1, 2, 3, 4, 5, 6, 7, 8. Similar way this one 1, 2, 3, 4, 5, 6, 7, 8. Similar way this one 1, 2, 3, 4, 5, 6, 7, 8. So if I write the same subnet mask, whatever the subnet mask 255, 255, 2550, I'm just writing in binary because the device understands only based on binary. So in general, by default, there are total 8 host bits. Total there are 8 zeros. So 8 host bits here, and remaining all are network. So one host portion, which means there are 8 host bits. So out of these 8 host bits, I don't need exactly 8, I just need only 6, which means from right side 1, 2, 3, 4, 5, 6, and remaining 2 bits I am converting them into network. Probably we can say the remaining 2 bits I am going to convert them in network, and the remaining 6 bits will be host bits. So from the right side you have to count host bits, and left side you have host bits. So probably left side you have network bits here. So which means out of total 8 host bits, I just need only 6 to be used. So if you remember in the previous, before we started the calculation, we discussed that we need to reduce the number of host bits, and by default there are 8. So how many we need to reduce depending upon the requirement. So as per my requirement 40, if I use only 6 bits as a host, that is enough as my requirement. So I'm just leaving 6 and remaining 2 I'm converting into network. So which means your total networks, or we can say you can use this formula also. Converted network bits is equal to, I got a formula here in my example here. I got a steps also here. Host bits required is 6, and converted network bits is equal to total host bits minus required host bits. So or you can do like this, total there are 8 host bits, in that I need 6. Total there are 8 host bits, I just need only 6, so which means remaining 2 gets converted. So total becomes how many? Total by default there are 8, by default there are 8, by default there are 8, which means by default there are 24 network bits plus 2 extra added. So it becomes 26 network bits. So now the tally of 24, 8. By default C class supports 24 network bits, and 8 host bits is changes to 26 and 6, which means there are 26 network bits and 6 host bits. So this is what we discussed initially before we started the subnetting calculations. This is what exactly happens here. So very important to understand this behavior, because in subnetting we are not doing anything, just we are manipulating the number of host bits and network bits. So now how many bits we need to convert or how many bits we need to reduce, it all depends upon the question, the requirement, the network size, what you require. So here we are just trying to take some examples, and we are simulating, assuming that this is my requirement and how the calculation process goes in case if I have this type of requirement. So this is very important, understanding the bits. So once you understand the bits here, now the next step is, if you want, you can just calculate how many subnetworks we get. Subnetwork means after dividing how many small networks you get, you can use 2 to the power of n value. N value is nothing but this is your n value, converted network bits, or we can say this is your n value, the extra bits, which means you get exactly 4 subnets. Which means if I divide a C class network and each network is 64, 64, 64, 64, I get exactly 4 hosts, 4 networks, and each network will have 64 addresses. So this formula will give some very clear short method of identifying or finding how many small networks we get after doing subnetting. And now the last thing is subnet mask. The next thing we need to write subnet mask. And if you add 8 bits, how much it is? So this is your subnet mask. This is your subnet mask. But it is in the form of binary language. And when we implement practically, we don't really write binary language. We need to write in decimal language. So probably if you add these 8 bits, it becomes 255. And if you add 8 bits, it becomes 255. And if you add this 8 bits, it becomes 255. So previously it was 255.255.255.0, which means there are 8 host bits. Now these two are no more hosts, they are network, which means they are ones. So we need to add 128 plus 64, it becomes 192. So this will be your subnet mask. So whenever you see this type of subnet mask, we call it as a customized subnet mask. This subnet mask has been extracted after after changing the bits from host to network as per the requirement. So this will be the subnet mask now. Now this is your subnet mask. When you change the bits, automatically the subnet mask also changes. Now it is actually the same binary decimal representation of your binary digits. So now the last thing we need to understand is the range. The last thing we need to understand is writing the range. The range always written based on 2 to the power of h value. Now if you see here, we just divided one C class network into 4 parts, right? So now the default range starts from this is my network, and the default range is 0 to 255 as per the default size. Now this default size is no more default, it is further divided into 4 networks. So here 2 to the power of h value is 2 to the power of 6 here. So 64 is the size of each network. You can see 64 is the size of each network, because after doing subnetting we got 6 host bits. So 6 host bits, which means 2 to the power of 6, 64 is the size, which means we have to group 64 addresses to become one network. So probably I'll start with any address here. You can say 0, 0, if start with 0, and group of 64 addresses means we are going to count 0 also, so it will be 0 to 63 becomes one network, 64 to 127 group of 64 addresses, 128 to 191, and 192 to 255. So the default size, which starts from 0 and ends on 255, has been divided into 4 networks, and 0 to 63 is one network, 64 to 1. So just we need to group 64 addresses. So either you can write like this, or if you just want to make it more simple, write down 0 plus 64 will be the next range, next network, plus 64 will be the next network, and plus 64 will be the next network. So if the next network starts on 64, which means my network ends on 63. So 0 to 63 becomes one network, 64 to 127 becomes one network, 128 to 191, because next door starts on 192, my network ends on 191 to 255 becomes one network. So same thing if you write in fair. Let's say if I write the same thing in simple, in fair, like 192.168.1, 192.168.1 remains the same on both the sides. So 192.168.1 remains the same. So the first 3 portions will never change, because in the C class the first 3 portions are standard common because of network portion. So the first address starts from 0, second network starts from 64, third network starts on 128, fourth network starts on 192. So 0 to 63 is one network, 64 to 127 is another network. So 128 to 191 is another network. So now after doing subnetting, this is one network, and this is your second network coming from 64 to 127, and this is your third network, and this is your fourth network. So now the default one network has been divided into 4 networks. So don't worry how they are different networks. I'll get into some more in detail in my next class, where I'll give some more in detail idea how they are different networks. But right now I just want you to understand and follow that they are different networks. And in this, the first address is network ID, and the last address is broadcast ID, which means you cannot use 0, you cannot use 63, because network ID and the broadcast ID of the first network. And whatever the addresses you cannot see here, which is in between 1 to 62, probably you can use those addresses. Similar way, 64 to 127, 64 is network ID for the second network, 127 is a broadcast ID for the second network. Similar way, 128 to 191, similar way 192 to 255. Okay, so This is how the calculation process goes. Okay, so now they become different networks. Now they are actually different networks. They will be different networks if I use the subnet mask of 255, 255, 255, 192. If I use this subnet mask, automatically the device will understand that okay, 192 means there are 6 host bits. So it will write down the range as per this, and it will understand that 0 is network ID, 63 is broadcast ID for this network. So it's no more a default network, it will be considered as a subnetwork. So similar way, any example like any FLSM calculation, mostly the steps remains the same. So first you have to identify the requirement. Based on that requirement, you have to finalize. You have to check which power value satisfies your condition. So in my case, it is 2 power of 6. So out of 64, 2 addresses I cannot use because network ID and the broadcast ID, which means out of this 62 addresses I can use. Means for every network, the first address we cannot use, the last address we cannot use. Whatever the addresses in between we can use. The same thing apply for second network, same thing apply for third network, same thing apply for fourth network. So each and every network we have 2 addresses, the first and the last, which we cannot use. So whatever I wrote here, it is your valid host addresses. So I get 64 size, that is the only possible size nearest as per my requirement. In that I cannot use 2 addresses. So required host bits are 6. So now after this you need to just find out how many total host bits we have in our example. The more you do it, you don't really need to write down all these binary steps. So this is just I followed for easy understanding. Once you are a little bit much comfortable with the calculations, and you'll find it more easier as you move on with more and more examples. So probably you can take another question like requirement is 30 host, and one more question requirement is 100 host. So probably when you try these examples in a similar step-by-step process, you'll find it more easier. So converted bits is equal to 2, which means to out of 8, I don't need 8, I just need only 6 bits. So remaining 2 I'm going to convert into network. So when you convert this, automatically subnet mask also changes because now these two are no more zeros, they are ones. So we need to write down the equivalent decimal value for this. So anyway, there is no need to calculate these subnets, just for understanding, because in the certification exams you'll be tested on some questions like this. So probably you should be very well aware of some shortcut methods or formulas which will help you to get the answer more quicker. So that will focus in our next advanced subnetting calculations. We'll see more in detail on that. So this session we are just getting into some very basic subnetting calculation by using C class, just to have a very good understanding on how the subnetting calculation process goes. So and finally writing the range. The range always written based on the size of the network. So by default there are 24 and 8 bits. So whenever there are 8 bits, the size of the network will be 2 to the power of 8 256, which is the default size. But after doing subnetting, it changes to 6, which means 2 to the power of 6, the size of the network is 64. When the size changes, automatically the range also changes. Now 0 to 63 becomes one network, 64 to 127 becomes another network, 128 to 191, 192 to 255. Okay, so I suggest you to just try to do this example. Try to make sure that you note down this example in the same step-by-step process, and you can probably try to do it step by step. And at the same time, I suggest you to also go through with some other examples. So I'll give some exercises for you. Probably you can try this example. Requirement is just 30 hosts. So you can try this example. We did 40. Similar way, you can try one more example. Requirement is 100 hosts, and probably requirement is 12 hosts. So in my next class, probably I'll try to do any one example. I'll do it just as a revision so that I can just quickly revise the same subnetting calculations. So make sure that you, before we continue with our next class, I just want to make sure that you practice this example, as it's more a step-by-step process of calculation. The more you do it, the more you'll find it easier. So initially, first time, you'll find a little bit complicated process initially because understanding the bits and all those things. But as you move on with more and more examples, probably you'll find it more and more easier. So it's about practice, the more you do it. So we still have some more sessions on subnetting that will be focusing in our next classes, where we get into some more advanced more number of, like, first we started with B class, C class. Probably now next class we also do some B class examples, and also we do some A class examples. So once we are done with this, we get into some main part called VLSM, and then finally we'll also works on some shortcut methods to answer some bits, especially when you are getting into certificate exams. You'll be tested, and when you face some interviews, written test, probably you'll tested on this, and some shortcut method which can be very useful, very handy, especially to get the answer submitting calculations more faster. So this bits shortcuts is a final step which is mandatory, you should know, okay, to have very good hands on. But for this, these are all foundations. So first you should have a step by step approach which I suggest, and many people really don't follow this step by step method. They try to skip some steps initially, so that is where they find problem here. So when they try to solve the bits, or when they try to understand the networks, they don't get the real correct answers because they don't have a proper foundation, because they really don't know the exact, they skip some steps. Again, they'll find problem here. So you cannot directly jump to shortcut methods without having a proper understanding on step by step process, how it goes exactly, how the calculation process goes, how the devices will do this. So that's what I mainly focus on the first two sessions. That one session we did today, probably we'll do another session on this step by step process. Finally, in the third session, I'll give some very good shortcut idea. By the time we start this third session, you should be very much aware of this step by step process. You should be very much comfortable with that. So once you are comfortable with this step by step process, the finally we'll try to focus on the third part, where we'll try to do all these calculations in a more faster manner, where you can get the answers, and also we'll discuss some bits on it. Okay, so I'll see you then in the next session, where we'll get into some more advanced submitting calculations with B class and A class. Okay.